Alright, for this lesson I'll show you how to rationalize the denominator. So let's start off with a radical. Let's say we have the square root of 2 times the square root of 3. When you're multiplying radicals, you can actually simplify it. So in this particular case, I can combine this to just one radical. So the square root of the two radicands, right? In this case, it's 2 and the 3. So I'll put those numbers as the product inside the radical, right? Because those two radicals were initially being multiplied. So I'm multiplying those two numbers as well. But now we can say, alright, so it's just the square root of 2 times 3, but we know 2 times 3 is just 6, okay? Alright, now let's say we have the square root of 7 times the square root of 7. Now what would happen? Okay, well, we'll do the exact same thing as before. We're going to make it into one radical, the square root of, in this case it's 7 and 7 is the product of those two radicals, so we'll combine the two radicands, right? So 7 times 7 inside one radical, and now when we do this out, we're going to get the square root of 49, right? Because 7 times 7 is just 49. But we all know the square root of 49 is just 7. So what happened here? Well, this tells you if you take the square root of any number times it with the square root of that same number, you're going to get that number, right? So for example, let's say we have, just take some random number, we'll call that random number happy face. So we'll say the square root of happy face times the square root of happy face again, so it's the same number here, and it's gonna equal, guess what, it's gonna equal that happy face. Now you can replace that happy face with any number, right? And this, if you're looking back at this example here, the happy face was 7, so the square root of 7 times the square root of 7 is just 7, right? Okay, so let's take a look at an expression here where the radical is in the denominator. So we'll take the square root of 1 over the square root of 5. Alright? We never want the radical to be in the denominator, right? So this is a big no-no. We don't want this. So you see a radical in the denominator, right? You don't want that. Right? So now what we have to do is rationalize it, right? So that's the process or the method. And to do that, we'll take the original expression, 1 over the square root of 5, right? And we want to multiply that by whatever that denominator is. In this case, it's the square root of 5. So we're going to multiply that by the square root of 5 over itself, right? So by multiplying it by the square root of 5 over square root of 5, this is just 1, right? We all know that the square root of 5 over the square root of 5 is just 1. This is equal to 1. So we're not changing the value of the original expression here, or the original number, right? So we can do that. The reason we're doing that is because we can simplify this to, right, 1 times radical 5 is just radical 5, right? But from the previous example, when you have the square root of 5 times the square root of 5, right, and the radicand is the same, the answer is just 5 for the denominator. right? Because when we multiply those two radicals, it's just 5. And the reason is, if you want to do like a side note on the bottom screen here, you can say, well, why is that the case? Well, think about it. The square root of 5 times the square root of 5 is equal to the square root of 25. And we know the square root of 25 is just 5. Right? So that's why it's the square root of 5 over 5 as our final answer. Right? And that's it, because there's no more radicals in the denominator. The denominator is just the number 5. Right? So the original number 1 over radical 5 right here, which we didn't want, right, because there's a radical in the denominator, is now this number here. And this is the number that we want. Okay, what would happen when we have, let's say, 1 over radical 2, or 1 over the square root of 2, and you're multiplying that by, let's say, the square root of 3 over 2. Okay, so we're multiplying two fractions here. So whenever you multiply fractions, you just multiply across, right? So what that means is you take the 1, multiply it with the radical 3, and then you take the radical 2, multiply that with the 2. So when you do the 1 times radical 3, that's just radical 3. Right? Divide, right? And then you do radical 2 times 2, that's just 2 radical 2. Right, we normally put the number first in front of the radical, right? But then we have a radical in the denominator, right? So we have this radical in the denominator, so we don't want that, right? We don't want that. So what do we have to do? Well, we're gonna have to rationalize it. Right, we're gonna have to rationalize the denominator, and let's make this, let's copy this all the way down here so we can see it better. So we have radical 3 over 2 radical 2. So we're gonna rationalize it by multiplying it by the square root of 2 over the square root of 2. Right, so because that's the radical. And we know that radical 2 with radical 2 is just 1, so we're not changing the original number here, so that's okay, right? Mathematically, that's okay. So now this becomes radical 3 times radical 2. If we multiply these two here, we're gonna get radical 6, right? And then the 2 you just leave in the front, but then we have a radical 2 times another radical 2, right? So we have this one here times this one, and we know that's just the number 2, or radical 4, but that's just 2. So now this simplifies to, so now we have radical 6, right? That's the numerator, over 2 times 2, which is 4. So now we no longer have the radical in the denominator. So we're all done here. So this is our final answer. We can't simplify it anymore, right?